Okay, so this is a controller? Okay, good. All right, so very nice to be here, and good morning, everyone. My name is Han, the founder and CEO of Jina AI. So we are based in Berlin, so if you are also in Berlin, so welcome to visit us as a Potsdamer Plus. Right? And today I'm going to talk about the, unlock the business value of the multimodal data, right? Which is a pretty new term, I believe, for a lot of people, right? And just to be aware, this is a sponsor talk, right? So you see our logo here, right? Anyway, right? So I would like to first give you a short intro about our company. We are a commercial open source software company working on MLOps platform for multimodal AI and neural search. We are growing very fast. Right now we have 52 people over the globe. Berlin is our headquarters. We also have office in California, in San Jose. And we are very awesome. Right? So, to know how awesome we are, so we develop a lot of products, right? So over the last 30 months, right? So some are closed source, some are open source. They cover end-to-end the developer journey of when you try to build a multimodal and cross-modal AI service, right? This is what we have done over the last 30 months, and this is our vision, right? To become the, like say, one-stop solution for MLOps on multimodal AI, right? So I keep mentioning this multimodal AI. So I will put the take-home message in front, right? So basically, if you ask me, like, what is this startup is about, right? So what is Jina AI is about? I usually, depending on who I'm talking to, I usually shift, interleave between these two narratives. One is, Jina AI is a MLOps platform for cross-modal and multimodal applications. This is usually when I talk to very data-centric persons, right? And if you only care about the applications, you don't care about the, whether it is multimodal, cross-modal, then I will switch my narrative to, neural search and creative AI. So in fact, those four things are not unrelated. They are very, closely related to each other, right? So this is also the second message I want to send, by this talk, which is super important. And the rest of the talk is basically explaining why this trend or paradigm shift makes sense, right? So I believe before 2020 or 2021, a lot of AI applications single modality, a focus on single modality, right? And especially from this year, we see, OpenAI, DALLE, and then Google Imagen, StableDiffusion, and there are a lot of diffusion-based model popping up, which basically pulling this AI from single modality to cross and multimodality, right? And neural search and creative AI are kind of the two very essential applications in the cross-model and multimodal domain, which I will explain why. All right, so this figure, I mean, if you have a camera, if you have a phone, better take a, take a picture of this photo, which is super important. And okay, but I guess right now you still don't know what I'm talking about, right? So cross-modal, multimodal, what does modality means? So the first topic of this talk is to understand modality. So let's just fly back to 2010, which is 12 years ago. And there was, I published a paper. This is when I did my, I guess, a master study first year. And there is an algorithm called latent dihedral allocation, which is a Bayesian model focused on text mining or text modeling, right? So very early stage AI. So today we call this kind of model as a shallow learning because right now we are in the deep learning summit, right? So I wonder if there's some like a summit called shallow learning summit. Okay, so what does this model do is right now if you look at it, it's very basic, right? But back in the days, it's like black magic. So it can extract a given corpus. Corpus means a lot of documents, text documents. So it can automatically clustering those words into different topics. So some people, for this reason, also call this model as a topic model, right? And so this is just one application, so very simple applications of textual data, right, on the textual data. But back in the days, I remember back in 2010, this method is super, super popular. It's like the go-to method when you do NLP, right? So if you don't know about this topic modeling or LDA, so you're kind of not in this community, right? So nowadays we see that there are a lot of NLP tasks can be enabled, by machine learning, right? So I just listed this top 20 NLP apps here, right? So this is about the textual modality, right? So let's also look at visual modality. So this is a data set. So I probably a lot of people know this data set is a fashion MNIST data set, which I published in 2017, right? Unfortunately, I come to this computer vision community much later than NLP, right? So I started my NLP back in 2009, and then the first paper I published on computer vision is actually in 2017, so 8 years after, right? But still, even in 2017, so most of the applications on computer vision is about single modality. So that means they only take the input of the image and they try to do some algorithm on that, and then probably also output some image. They don't crossing other modality like textual, audio, or whatever, right? So when I propose this data set, the main idea is to use this data set as a machine learning standard benchmark data set for convolutional neural network. Because back in the days, everybody is using MNIST data set, which is a handwritten digit proposed by Yan LeGong in 2000, not in 2000, but in 1990, right? So that was 30 years old, right? And it's super easy, so a lot of very trivial algorithm. You don't need deep learning. A simple SVM, a support vector machine, or even logistic regression can give you like 95% of accuracy. So that's why I propose this data set, which is a little bit challenger compared to MNIST, but shares a common data format compared to the original MNIST. So developers can easily use this data set in their benchmark academic research and so on. Right. So this paper right now has more than 4,000 citations on Google Scholar. And yes, so these are the common tasks. So like, if we compare this computer vision to the NLP, we also have like a common computer vision task that we can, that can be enabled by machine learning, right? So those are the top 20 computer vision tasks. And the same goes with audio and speech data, right? Acoustic modality, right? So I also summarize this top 20. I'm not really into this audio and speech data analysis or intelligence, so that's why I don't give any examples here. But as you can see, if we talk about single modality, right? So the upper side of this slide basically very nicely summarize the single modality, right? So the knowledge is learned from and applied to one data modality only. So if you look at these applications that are summarized beforehand, so those three domains are kind of orthogonal to each other, right? So that's why you have a cube there, right? So the boundary is very clear. But when we talk about multimodal AI, the knowledge is actually learned from multiple data modalities and then applied to different modalities. The task can be shared and transferred to multiple modalities, right? So this is basically the difference between single modality AI and multimodal AI. So how is that possible? So what is like the key technology enabler for this transition, for this paradigm shift? It's basically there are two key technologies. So one is representation learning. The other is transfer learning. So both happened roughly between 2018 and 2019. Representation learning basically allows you can use deep learning model to learn a common vector representation or tensor representation for different kind of modalities, right? So you can use CNN, you can use LSTM, you can use BERT, you can use transformer to learn a common knowledge, common vector representation or dense representation of image, text, video, audio, all this kind of thing. And then transfer learning allows people to just fine-tune the model on the domain-specific data without retrain the model from scratch. Right? So these are the two technologies that somehow boost this paradigm shift over the last 2 years. Yeah. So there is a very fun story. Like back in 2010, I also published a paper about linking the image modality with audio modality. Right? So this is called, my paper is called this Towards Artificial Synesthesia. Right? So the idea is you see a picture of blue ocean, and then the algorithm will try to find out the wave splash, this kind of audios from the database. Right? So that was like 12 years ago. And back in the days, I proposed this very complicated Bayesian model. And it doesn't work, right? It doesn't work as good as if we use deep learning models. But I think this is very, very interesting. Let's say early cross-model attempts, right? And then, by the way, it is also published in NIPS, a Neural IPS workshop. So it's so back in the days, a lot of people believe in this Bayesian model, and try to use Bayesian model to do this cross-model things. Right. Okay, so if we look at the enterprise data, right? So we know inside the company you have pictures, you have document, you have PDF, and then inside the PDF you have text, you have images, you also have audio clip, a recording from the Zoom conference. So you have a lot of multimodal data inside the enterprise, right? So most of the current machine learning algorithm, as I said, only work on single modality, right? So you just try to grab the knowledge from your PDF and then try to only work on the PDF. Try to grab the knowledge from your pictures and then only work on the pictures, right? So according to this paradigm shift, so we will see more and more machine learning algorithm or AI algorithm focusing on exploring the the crossing relationship between all these modalities. Okay, so now let's say we have this kind of modality relationship, right? Cross-model relationship. So what can we do? So there are two very essential applications of AI. So one is a search and the other is create, right? So let's look at this search and create, right? So I will just talk about neural search because, if you're talking about like a Control F and then search a keyword inside your Word document, this is not something that very interesting, right? So this is string matching, exact string matching is something that has been studied for at least 60 years since computer is invented, right? So we are talking about neural search where the input is a text and then you search for images, and then the input is an image, you search for similar images, right? So these are something that non-trivial. You cannot just use grep, you cannot just use string matching to do the work. You have to use some deep learning algorithm, right? You have to learn some cross-model relationship between the image and text, right? So that is search. And then the other is create, right? So create is something like a DALLE, OpenAI DALLE, Stable Diffusion. But in this case, all of the things are created by, by one of our open source product in Jina AI. It's called DALLE Flow, right? It's a DALLE and then a diffusion model. Yes. So you can create images from text. You can also create images from images. So you basically use an image as an initial image and then create other images out of that, right? Okay, so if you look at the search and create, then you immediately realize that they are just so similar. If you just look at the function signature, you cannot even tell what is what, right? So I put 4 things together, and then I mask out all this function name, right? So I just put question mark there to replace the original function name, create and search. And then you immediately realize that, okay, it's not very differentiable, right? It's not very, you cannot tell the difference between these two things, right? They all receive the same input and then give you the same output, right? More or less the same output. Right? So why is that? Because there is a duality of search and create. Right? So that's very simple answer. Right? So basically, the duality comes from, so once you have this very fuzzy, relationship between all this data modality, right? Text, image, audio, 3D mesh, human face, movie, audio, time series, all these kind of things, right? So it's like a very fuzzy doll, right? And then once you somehow figure out the relationship between all these modalities, right? It's like you can extract the DNA out of this thing, right? And then you can use this DNA to do either search and create, right? So search is basically find what you need, and create is basically make what you need, right? So this is a very good example, analogy, right? So you can use this search to build this kind of, this is called phylogenetic. I forgot the name of these things. It's a tree of life, right? So basically you can sort all these animals by their DNA and find out, okay, what animal is closely related to other animals. All right, so this is like search. And then you can also use it for create. Right. I hope everybody sees the movie and get the reference here. Right. So of course there is a better analogy which I like a lot. Right. So basically this is I don't know if you watched these two anime before. Right. So one is Doraemon, is very popular at least in East Asia. Right. And then the other is Rick and Morty, and Rick, this Grandpa Rick. So there is some similarity between these two guys. So this Doraemon always try to find out something existing from his magic pocket, right? So, but he never invent something new. He always try to satisfy whatever the boys need, and then try to give some magic item from his magic pocket, right? And then this Grandpa Rick is always invent something new. He doesn't try to grab something out of the box, but he invents something new. So this is like creative AI and neural search, right? I try to use this example a lot until one day I show this to my colleague, and then my colleagues are all from Europe, so they don't get the reference of this this guy Doraemon, and they saw this he's doing something dirty. So that's why I try to avoid these things in the speech. Right? Anyway, so what does Jina AI offer again? Right. So I think this is about time. Okay. So I probably finished earlier. So what does Jina AI offer again? Right. So we basically provide you the end-to-end framework that covers everything, right? So from the time you are prototyping such multimodal applications, especially neural search and creative AI, so you can use Docker Array, one of our open source project, to prototype, right? So once the prototype is done, you can make it a service, right? So there's make it as a cloud native service using Kubernetes, all this kind of things, but everything is already incorporated into Jina framework. And finally, deploy and hosting. Right. So there are also some it's a very nice and a very efficient framework which saves you a lot of effort. So you don't have to do all these kind of engineering things, and you don't have to do this scalability, concurrency, all these kind of things. It's automatically handled, so you can easily define your YAML file, and then it auto scale or scale on demand. Right. And it has very nice container integration with Docker, and also serverless, all these kind of things allows you to stabilize your development environment, and also to make your service more cloud native. Right? And of course, there are some observability tools such as Prometheus, Grafana, which is automatically available when you develop applications using Jina. So, and finally, don't forget, this is our big picture of the Jina AI as a company, and this is what we are visioning about the future of MLOps, of multimodal applications, right? Okay, then that's it. Then thanks for your attention. So if you are interested in Jina AI, so feel free to come to these links as I showed here. And also we are in Post Demo Plus. Feel free to visit us anytime.